Hey there, welcome back. Jason here with another code review. This one I think is going to be pretty interesting. It's quite a bit different from the other code reviews that I've done, and it's mostly just focused on a single system, a state machine system. This was submitted by Andy, and I'm going to run you through the gameplay real quick, and then we're just going to dive right into this state machine. So here you see I've got a character. Oh, I'm already getting shot at. And if you look here, he's got the top-down view, and it's actually in top down with isometric on, so you can actually see all of the things that are looking around and chasing me. There's ghosts, and then there are these turrets. The ghost, oh, there he is. You see, when they get in front of them, let's see if I can find one. There we go. Watch the little indicators in there, and you'll see that as soon as I'm in his line of sight, any second now, little ghost. Oh, he's too fast for me. But as soon as I get into the line of sight of these things, they should start rendering a little red arrow. There we go. And you can see he's chasing me. And then once I ditch him, oh, if I can get away. Here, let's just let him kill me. So he blows up when he hits me. They follow me around and they chase me. Otherwise, they're in that wander state. And I can also, I just want to see if I can get this one time. Let's run up in front of him. And I'm going to lose him. So I want to run in front, get him aggro. So he's chasing me. There we go. And then if I can just lose him and lose line of sight, like I did running around that corner, they'll stop chasing me. So let's take a look at the code. We're going to go into the scripts folder, and you see there's not a whole lot here. It's pretty clean. There's just a state machine and a bunch of different states. And then there are a couple controllers. There's a ghost controller and an obstacle controller. But I think that's just about it. So let's dive in. Well, first let's expand out the scene and take a look. You see here we've got 2 ghosts and 3 turrets, which kind of lines up with what we were seeing. Now the ghost scripts are actually down here on this magic cube child, and there's a ghost feedback and a ghost controller. I think before I show the state machine, let me just show the feedback one because it's nice and simple. So this script is just responsible for showing things to the player. So things like particle systems, changing the color of the material on this guy. So remember when he was chasing me, he turned red. He's just got a chase option or a chase method here. Turns off particles, turns it red. An alert that goes yellow, and an explosion that plays some explosion particles. And you get the idea. This is really just a nice lightweight wrapper over setting up a bunch of different visual effects, which I kind of like. It feels pretty clean, and there's only one little spot. Now if you had a huge selection of things that could be there visually, might not be able to fit it all into one clean script, but here this is perfect. We're at 60 lines and it's nice and tiny. Now I want to go over to the actual ghost controller. So this is what's handling all these guys running around and chasing me, kind of. It's really just setting up the state machine though. So if you look here, he's got a Waypoints array, or yeah, is this an array? Let me just look at this. No, it's an object of waypoints. So you give it a waypoint, I think it goes to the next one. A speed variable, and then a target. Right now it looks like we're just targeting the player. There's only one player, and it's pretty simple. I want to go into the state machine stuff though. So in start, this is where it gets interesting. Here you'll see that he's instantiating 5 different states. So there's a patrol state, which I believe is just that default state. So this is when they're running around, roaming around. So he creates this new state, passes in the controller as the first parameter, and then the target as the second, the speed, and the obstacles. Here, let's just hit comma there, and you can see the different parameters required for this ghost patrol state. And then we do a ghost alert state, and you notice here that he's passing in patrol state. So what's happening here is that after each state is complete, they kind of can go to a next state. So think of it as kind of a linear system or a circle where they're going around, but there are ways to shortcut across the different states. So patrol state is here and does not have another state that it falls back to. But alert state will go back to a patrol state, so we'll cooldown state. Explosion state goes to a cooldown state. So imagine like we hit, we explode, we go to a cooldown, and then we go back into patrolling. And then chase state goes into explosion state. So that's assuming that it hits me, it is going to switch to that state. Otherwise, we're going to bounce back over to that patrol state if we don't hit the player. And then the way that he's doing the the bouncing around between different states is with this add transition stuff. So here you'll see that on patrol state, he's adding a transition to chase state if player site ghost input is passed in. So imagine it's patrolling around, it needs to go to chase as soon as it sees an enemy. This is the way that he's got it set up to do it. And it feels and looks pretty clean. It's pretty easy to understand as well. Chase state has 2 transitions out, again, aside from the default transition out. And that's if the player's in reach, it goes to explosion. If they go out of sight, it goes back to alert state. And then alert state has a timeout where it just goes back to patrol state, or it goes into chase state if it sees the player again. So I think the idea here is it's supposed to stop and then go chasing. I think right now it actually just kind of jumps right back into patrol state. And then there's the explode one, of course, does the same exact thing. So if it explodes, goes to cooldown, and then once the cooldown is ended, goes back to patrol. And then right here on 51 is where he's actually creating this state machine and then passing in patrol state as the default state. So just creating it here didn't make it the default. It did have to be passed into the state machine. Now we're going to take a look at the state machine specifics and how that all works in just a minute. But first, let's just go through the rest of this script. So in update is simply calling state machine.update, which is just forcing the state machine to do whatever it needs to do for the current state. And then he checks to see if the player's in sight, and if they are, he passes in or feeds in this player site transition or ghost input, I guess is what it's called. So it's just telling it, hey, whatever state you're in, just know that we can now see the player. Otherwise, it passes in this out of sight or off sight, which just means like, if we went around a corner and ditched the ghost, it's no longer going to see us, and the ghost needs to know that. So this is essentially sending in some data to the ghost so that about basically what it knows, what the knowledge is of this ghost into the state machine. So sometimes it's done like this, we're just passing a single thing. Sometimes there's a reference to state. Sometimes pass in a whole bunch of state. It really depends. In this case, it's nice and simple. We're just passing in a single variable here, a single enum for an input. Now, insight, I don't really want to dive into this too much, but you'll see it's pretty simple. It's just doing a quick position check to make sure that they're in range first. There's a range variable here. Then checking to make sure that the angle is valid. And then finally going through and just looking at obstacles and making sure that we have actual clear line of sight. There isn't a wall or something else blocking. And then here, these are going to look familiar. These are just wrapping to that what was it called? Let's go back to the script now. The ghost feedback. That's right. So he's wrapping in, oh, yeah, it says feedback right there. So he's just making those accessible, I think, from the states is the goal, because he's passing this in, not passing in the feedback objects. So it's just kind of a wrapper on top of those. And then we got the gizmos here for drawing those lines. That was the yellow lines and then the red line if we see something. That's right here. If in sight, it's drawing that red line. Okay, so now let's dive into that actual state machine. And to do that, I'm just going to go right up to where it's instantiated, and let's just hit F12. Dive right in. So the state machine, you'll see, takes that initial state, that's the patrol state being passed in, and gets set to the current state. And then in update, it just says next state equals current state dot update. So what's happening here is each update on the actual state can just return back a new state, which is exactly how I like to do it in my projects too. So if I have a state machine and it can switch states, it almost always just returns back the new state. It's either the current state that it's already in, or nothing, or a new state. In this case, it looks like it's going to be either nothing or the new state, because if we passed in the current state, well, you'll see what would happen here. So if we call change state with this next state, it just says right here, if next state is not null, exit the current state, enter the new one. So it must pass back a null state for when it doesn't want to do a transition. Otherwise, we'd be going into an exit and an enter, which I think is perfectly fine. It's actually probably the cleanest way to do this. All right, so then once it does that, it exits the old state, enters a new one, and then sets the new current state. So this is kind of the fundamental base of a state machine. You essentially update the current state, and then that state tells you if you should switch to a new state. And then with this feed option, we have the ability to force change to a new state. So this is where he's passing in the things like I saw line of sight. Here, let's hit Shift F12. And if you look right here, this is getting passed in, it looks like basically every frame though. I'm not sure I would necessarily pass this in every frame, but let's see why that's happening and see if it makes sense or if it could be simplified just a little bit. So in the current state, we were calling update. Now let's just step through and look at what this would look like on a patrol state. So I've got patrol right here. So update is just going to call in. It's going to call move to waypoints and avoid. And then it just returns null. So it never returns back a new state. Okay. And then here, I don't think we need to go through all this code, but you can just assume this is going to find the next waypoint. It's going to look for obstacles, and then it's going to try to avoid those obstacles to get to the waypoint. So if it needs to go around a wall or something, it's going to do that. And that's the entirety of this state. It's really just moving. It looks like an old method that's not used, but it looks like it's just moving around to the next waypoint and not doing anything else. So where's that feed? Let's see. Let's go in. Let's take a... I don't see that here. So that must be getting dealt with. Ah, yes. It's getting dealt with on the base state. So here, let's go back to the Ghost Patrol. Ghost Patrol is a state that's from the base class of state and takes a ghost inputs. Okay, so then when the transitions were added, it's adding it with this key and the state. And then it's just saying, hey, if our transitions contain whatever this key is, do that switch. I like this. So let's go back to the Ghost one more time, GhostController, and just kind of really try to understand what's happening here. So here on the patrol state, we're adding a transition for player sight, and it's going to chase state. So if we're in our state base class, let's see, go to Ghost Patrol, go to state. So transition for the ghost seeing the player is added right here. And then we're just checking to see if there is one for this ghost added to player, or ghost saw the player. And if there is, it's going to return that new state. So right here, it's going to return chase state. So if feed is called with player sight, it's going to return back chase state, and then the state machine is going to switch to that. So then in our GhostController, right here. So right here, if we pass in player sight, we're going to do something while we're in patrol state. If we pass in player offsite, we're actually doing absolutely nothing because that's not registered here. Now in chase state, you'll see that player offsite is registered. So when we pass that in right here, when we lose it, if we're in chase state, it's actually just going to return back and switch to alert state. So that means that it lost the sight of the object. So let's take a look at another state. Let's look at the chase state. So let's see where it was chase state right here, and just F12. And we'll go right in, and here again, remember they're passing in the ghost. Is the ghost passed in every time? Yes. So that's one thing I would definitely change. I would just move that up to the base class. The state machine's pretty generic right now. It doesn't need to be that generic when we have the actual ghost on everything. I'd just pass that in and pass that straight up to the base class. Let's take a look at what this is doing though, and then I think I'll make that change. So we cache the ghost, cache the speed, the target, the next state, and the visible layers. And then on enter ghost.chase, I think this is just wrapping that feedback, remember, showing what did it do for a chase? Oh, it turns red, that's right, and turns off the particles. So it starts on enter, just changes the visuals, and then in update we call follow player. Follow player just looks at the direction, and then it looks like slowly rotates towards them, and then moves forward. You know, it's turning and moving, basically. It's following the player. Nothing special. And then it checks to see if we're in explosion range, and if we are, it returns back out the next state. Okay, that makes sense. The next state is going to be explode when we get into explosion range. I'd probably rename this from explosion range to just range or something, but I think it's not a big deal. And then otherwise we return back null. Yeah, I really like this. Like I said, I think it really feels clean. But I do want to change this up just a little bit. On the ghost chase, or on the state in general, I think I want to push this up a layer. So we want to like promote this. Here, let's cut that. I think I'd promote it right up into here. So I'd have the ghost controller, and then I'd add a constructor, and we'd take a ghost controller ghost and just set it there. Now this will require me to go through the others. Oh, nope, I would not do this. I lied. So after thinking it through and then looking, we have turrets. This totally makes sense that it's on a level here for the ghost. So we'd say private ghost controller ghost. So perhaps I'd add a ghost states that just shares this, but now that I think about it more, and the fact that this is being used a little bit more generically than just on a ghost, I don't think I would even do that. I think it's perfect just the way it is there. I don't think it makes much sense to add in that other class that I was just thinking through. It's always interesting going through these things, figuring stuff out like that. So let's take a look at the turret states. So here's that turret idle. And you see here, it just passes in, again, a turret instead of a ghost. Why my original idea was terrible. And then on enter goes into idle, which is just another one of those visuals. And then update, it's doing a spin. Perfect. So let's see what a turret controller looks like. Turret controller has an idle state, passes that in. A turret cooldown, which, let's see, goes into an idle state. And then a shoot state, which I assume is going into the cooldown state. Yep. Then transitions, it's using the exact same kind of system, although it's using turret inputs.player site. I wonder if that could probably be a little bit more generic. This is one case where I think like the turret and the ghost, they're really doing the same thing for a player site. Like they just care whether or not we saw a player. I don't think these need to be separate enums. In fact, cooldowns and cooldown. Yeah, this all feels. This is one part I think that I would change after thinking it through some more, and just probably reuse those existing ones or make slightly more generic like state machine inputs if they're all going to be the same player site and cooldown. And yeah, if it ends up that they're going to be very different, then maybe they stay separated. But right now it seems like they're all kind of the same. In fact, I'm guessing that the insight code, yeah, this could all be shared across both of those, if I'm understanding. Yeah, it looks, I think it's exactly the same. Let's take a quick look. Let's pull up Ghost Controller side by side with Turret Controller. Yes, these are the same. So this is definitely an area where a little bit of cleanup could be done, and this could just be refactored into a base class, or really, let me think. What in here? We've got target, just passed in. We've got the transform. We've got the range. Just looking to see if there's anything that's really specific to this. No. So we couldn't easily just maybe we could just turn this into an extension method. I don't know. Part of the problem here is that they're totally separate classes. And yeah, let's do it. Let's just make this change. Sorry, I'm just thinking out loud. I'm going to take this isInsight and turn it into an extension method. So to do that, we'll just create a new class. Do it right down here. Public static class. And I'll call this site extensions. And then we're going to add a method for isInsight. So do public static bool isInsight. And then we need this transform source, or let's call it transform. Maybe I should name this transform extensions. I'll name it transform site extensions. There we go. And then we need a range and an angle. So say float, angle, float, range. And I'm using the underscores just so that I don't have to change the code here. And then we'll do a rename real quick after that. So we'll go up here, we'll take this whole isInSight and just cut it. And paste it right into here. And if we don't have any errors, okay, oh, we need a target. So let's take a, what is our target type again? Hopefully it's just a transform. Where is that passed in? Oh, yeah, isInSight takes in a transform target. Okay, so let's add that in as well. So just say transform target. I don't spell target right. Let's copy and paste target so I can get it spelled right. Oh, and then what's visible? So that was the layer mask, right? Let's see. Yep, a layer mask named visibles. So here we'll just add that as the final parameter. Cool. So now I've got an extension method that I can use across both of these. Now I'm going to rename these and get rid of the underscores just to make it really explicit that we're not using member variables here. This is just an extension method. And then I'm going to take this class, hit control period, and move it to its own file. Now, what we can do is go back here, and where are we checking isInSight? With player target right there. You can actually delete that, delete. And then we say isInSight player target, comma, let's see. Oh, wait, first we need, we're not on the transform right now. Let's look at that extension method one more time. So, let's see, extensions. Since we're using the type of transform for this, it's only going to extend a transform object. So we'd only be able to see isInSight on the transform. Now, if I want, I could also just change this to be mono behavior so that it shows up for every mono behavior. I think I'm going to leave it as a transform one though for now. Just know that it wouldn't really make a big difference. We just have to get the transform from the mono behavior. In fact, we could even add it like, if we copied this, add, and went mono behavior, and like maybe called this source, we could return back source.transform.isInSight and then pass in all these variables. Let's just do it. Target, comma angle, comma range, comma visibles. So now we could call it on transform or on mono behavior, and it'll just get the transform. Now if we go back over to our controller, let's see, isInSight should actually exist because we're now on a mono behavior. Is it not showing up? See. All right, here, let's just do it with the transform. So just do transform dot, and then we have isInSight, and then we need to pass in all those variables. So we have the player target, we have our angle, just underscore angle, and then our range, underscore range, and then our visibles. Which, let's get the underscore there. Let's keep it nice and consistent. So now you can see we can just call this without having this code in here. Oh, we do need to call it again down here though. So we need transform dot isInSight, player target, comma angle, comma range, comma visibles. There we go. So it's worth noting we are having to pass in these parameters, but we're no longer having to duplicate code. So now I've got it in the GhostController. I can just go over to the turret controller and delete. Don't need that anymore. And then let's see, where are we at? Right here, we'll just do transform.isInSight, player target, angle, range, visibles, and again I'm going to rename the visibles just to keep them consistent. Let's put that on a new line too, make it a little bit easier to read. So there we go. Now I've just cleaned it up a tiny bit with a simple extension method. This could also just be a static method. I just generally prefer extension methods. Feel like they just seem and feel a little bit cleaner, assuming that you know what they are and what they're doing. If you've never used extension methods, by the way, definitely go check out some videos on them. They're super helpful. There are a lot of really cool extension methods that I use all the time for things like flattening out vectors, or just even simple checks like these isInSight type checks. If I want to know if I can directly see an object from another object, I don't want to rewrite the raycast code every single time. Just use an extension method that does it. Okay, I think this is good. I want to give it a try real quick. Run around, make sure I didn't break anything, and then I think kind of wrap this up. Like I said, I really like this system. I felt like it was a pretty damn good and clean implementation of a state machine. If you're looking at doing state machines, another option on top of doing these code-driven ones. Did I break something? Maybe I did break something. Oh, I don't know. Interesting. Let's see what I broke. Now I'm just curious. It does seem like I killed the code. Well, first let's see if the turtle will kill me. Okay, turret shoots. Did we get an error? No? Okay, let's see why this ghost didn't blow up. Come on, ghosty. I get the feeling that I broke something in my minor little code change. There, do an attach. And then see if ghost explosion state is ever getting called. There we go. Bam. So we're never getting into... Oh, wait. No, this isn't. I put the breakpoint on the constructor. We need it on the interstate part. There we go. Well, let's select that ghost. Now, one thing I do like to add on these state machines, by the way, is just a nice way of debugging the existing state or the current state. I usually like to put some text over their head or something else visible that makes it easy to tell what's going on with them. Let's select this ghost. Oh, whoops. Let's get out of this view. There we go. Let's go find our ghost. Which ghost is it? It's this guy. Okay, so it is that. It was the one I had selected. Okay, and let's go to debug view real quick. We're probably not going to be able to see much. Oh, never mind. I figured out what the problem was. It's actually not a code change. Well, it kind of was. I renamed visibles, and it was a serialized field, so the serialized field value got lost. So if we go down to these ghosts, and actually just select everything or something that the player layer is on, it'll work fine. Again, the problem was just that the, let's go to that GhostController real quick. The GhostController visual, or wait, what was it called? Visibles. So this right here, it's actually so let's make that private. It's a serialized field that's getting set in the editor. And I did not take that into account when I renamed it and just lost the values that were there. Now there is an attribute I could have used, like, what is it, previously serialized as, or I think it's, wait, let's try, is it formerly? Yeah, formerly serialized as, and then I could have given it the name visibles, like that. If I had done that before running, I would have kept the correct values and not lost at all. So that was all it was. Anyway, again, I just really wanted to say that I really love state machines in general. I think that they work great for games like this. If you're interested in doing a code-based one, this is a pretty clean example to follow. If you're more looking for a visual one, I've played with a couple of the different systems like Playmaker and Bolt. A couple other smaller ones, Rain too, which is a slightly different machine. It's not really a state machine. It's different enough from the other two. But I would definitely try out the Bolt scripting for their FSM system. You can also use the built-in mechanism system for doing these visual trees. It's essentially what it is. You can hook in code there. I found that the Bolt one was a little bit cleaner, a little bit easier to understand what's going on. But again, if you just want to do a simple code one too, they're not hard to do. It's just a matter of understanding kind of how it all works, how the fundamentals go together, and then putting in some decent debug information for yourself so you can see these state transitions and see what's happening. I think with the visual effects that he's got added in here, the color changing and all that, really goes a whole way, or it adds a lot to make it easy to tell what's going on, so you may not need as much debugging. So something like that, or a text thing over their heads or something to show what they're doing. Like I said, it'll help a lot. Anyway, I'll quit rambling about state machines. I just want to say again, I love the code, love the project. It was a lot of fun checking it out. highly recommend anybody looking at doing a state machine just go through this and build your own, play with it, try to understand it all. And now I'm really going to shut up. All right, thanks for watching. Don't forget to like, subscribe, and all that stuff. And if you have code of your own that you want to see reviewed, you want to see me tear through it and totally break stuff, please just shoot me an email, send me over the code with just in a link. Just be sure that you're okay with it being shared publicly, and I'll try to get to them as quick as possible.